Hello, my fellow MENA viewers, and welcome on today's episode. So, on today's episode, we will be answering this GCE 2025 question 3A. As you can see, the question is concerning a pulley system. So, the question did not give me this figure or this diagram. I'm the one who has drawn it based on the parameters or the data that I obtained from the question. So, you should be able to come out with figures like this or diagrams like this after you've read a particular question that concerns a pulley system. So the question says that there are two masses, P and Q, and the mass P lies on an inclined plane that has been inclined at an angle of 60 degrees, and it has a mass of 4 kilograms. And this mass P is connected to a pulley that links another mass Q that is hanging freely and having a mass of 6 kilograms. So the question has asked us to take G to be 10. That is why you see that the weight of P is 40 and the weight of Q is 60, since I've just multiplied their masses with the acceleration due to gravity. So 4 times 10 gives me 40 and 6 times 10 gives me 60. So before I dive into solving this question, I would like to say that if you are a student who offers math mechanics, you should better go and grab a book and a pen and join me as I solve this question. So whenever you have a question like this, the first thing that you need to do is for you to resolve the weight of the block or the mass that lies on the inclined plane. And how do we do that? So we have to resolve this weight, which is 40 newtons, because this 40 newtons is acting now at an angle of 60 degrees since it is lying on an inclined plane. So we need to resolve this weight into the components that act along the plane or parallel to the plane, and the components that act perpendicularly or normally to the plane. So we need to have a component of the weight that acts in this direction, which is along the plane, and another component of the weight that acts perpendicularly to the plane. So this gives me, for you to have the components of the weight that acts along the plane, you simply take the weight, which is 40, and you multiply it by sine of the angle at which the plane is inclined at. So you have 40 times 60. For you to have the components of the weight that act perpendicularly to the plane, you take the weight, which is 40, and you multiply it by the cos of the angle at which the plane is inclined at. So the question says that this plane is smooth. That is why I've not included friction. Had it been that the plane was a rough plane, I would have included friction, and the friction would be acting downwards, since I've decided to choose the upward direction to be the direction of motion. As you can see, I've indicated here. So this is the direction of motion, and this is the direction of motion for mass Q. And the question further says that the string is light, and when the string is light, it shows that the tension in the string is constant, it doesn't change. And the string is also inextensible. When the string is inextensible, it shows that the particles move with the same acceleration. So the acceleration with which P moves is the same acceleration with which Q moves, since the string is inextensible. Now, when you have questions on a pulley system like this, you have to make use of Newton's second law of motion. Now, somebody would ask that, what is Newton's second law of motion? Mathematically, it is written as F is equals to ma. So, Newton's second law of motion states that the rate of change of linear momentum of a body is directly proportional to the net or resultant force of that body, and this change takes place in the direction of the force. So mathematically, this is how it is written. Now, I'm going to apply this Newton's second law on each of these masses. So I'm going to apply Newton's second law on mass P and also on mass Q. So let me start by applying this Newton's second law on mass P. So for mass P, we have two forces that are acting on it, which are the tension on the string and also the weight of mass P that acts along the plane. So since this is the direction of motion, I'm going to have tension minus 40 sine 60 degrees to be equal to, so this is the net force that is acting on mass P, or this is the resultant force that is acting on mass P. It should be equivalent to the mass of P, which is what? 4 times the acceleration with which P moves, which is A in this case. So this becomes my equation 1. I'll apply Newton's second law on mass cure as well. For mass cure, this is the direction of motion. So I'm going to have 60 minus the tension on the string. So this is the resultant force that is acting on cure. It should be equivalent to the mass, which is what? 6 times the acceleration with which it moves. So this gives me equation 2. So now I have two equations that are made up of two unknowns, which are the tension and the acceleration. So I need to solve this equation simultaneously, and if I decide to take equation 2 plus equation 1, this implies, or this gives me 60 minus 40 sine 60. Sine 60 is the same as root 3 on 2. So this is the same as 20 root 3. So this gives me 60 minus 20 root 3. Since sine 60 is root 3 on 2, 2 will cancel 40, or 2 will go into 40 20 times. So I'm left with 20 root 3 should be equal to, remember the t's cancel out, negative c plus t gives me 0. I'm now left with 6a plus 4a, that gives me 10a. So this implies 10a should be equal to 60 minus 20 root 3. Therefore, my a in this case would be, if I divide all through by 10, I'm going to have 6 minus 2 root 3. All these meters per second square. So this is the acceleration with which the particles P and Q move with. So this is their acceleration. Now for me to determine the tension, we simply substitute this value of A into any of these equations and determine the value of T. We can substitute it in equation 2. So from equation 2, this implies 60 minus tension is equals to 6 into 6 minus 2 root 3. So this implies tension in this case would be 60 minus 36, 60 minus 36 minus 12 root 3. When I expand this, 6 times 6 gives me 36, 6 times 2 gives me 12. So it is negative 12 since this is negative 2. Now when it comes this way, I have negative. So therefore, the tension in this case would be 60 minus 36, that gives me 24. 24. Then minus, that gives me plus 12 root 3. All this Newton. So this is the tension on the string. Then this is the acceleration with which the particles move at. So there is a B part of this question, and question now has said that the plane is not smooth, that is, the plane is rough, and it has given us the coefficient of friction between the plane and the mass scale to be what? 3 all over 5. And the question has asked us to determine the tension on the string and the acceleration of the particles. So we need to first of all determine the friction. We need to first of all determine the friction of this plane. And how do you obtain the friction of this plane? The friction of this plane is obtained using this relationship, which is from frictional force is equal to coefficient of friction times normal reaction. So this implies this is the friction, then this is the normal reaction. This is the components of the weight that act perpendicularly to the plane. So it shows that the frictional force in this case is equal to 3 all over 5 times 40 cos 60 degrees. So this implies the frictional force is equals to the weight divided by 5 times 40 times cos 60 degrees is a half. So this gives me 5 goes here, 1 time 5 goes here 8 times, 2 goes here, 1 time 2 goes into 8 4 times. So I'm left with 12 newtons. So it shows that the friction of the plane in this case is 12 newtons. Now we are going to apply Newton's second law of motion on each of these masses. So from Newton's second law of motion, which states that the net force or the resultant force acting on the body is equivalent to the mass of that body times its acceleration. Now applying this Newton's second law on mass P, this implies for mass P, we are going to have the tension minus. Now we have two forces acting in the opposite direction, which are the weight of mass P, that is along the plane, and the frictional force. So I have 40 sine 60 degrees plus 12. So be equivalent to its mass times its acceleration. So this simplifies to tension minus sine 60, like I said, is root 3 on 2. So this gives me 20 root 3 plus 12. So be equal to 4a. So this is my equation 1. Applying Newton's second law on mass Q, this implies 60 minus the tension on the string. 60 minus the tension on the string will be equal to 6a. So this gives me equation 2. So I now have two equations containing two unknowns, which are the tension and the acceleration, for me to solve simultaneously. So if I take equation 2 plus equation 1, equation 2 plus equation 1 implies 60 minus 20 root 3 plus 12 should be equivalent to 10a, since the tensions cancel out. So I'm now left with 60 minus 20 root 3 plus 12a. So this implies 10a to be equal to, this implies 10a will be equal to 60 minus 12, that gives me 48. 48 minus 20 root 3. So dividing by 10, if I divide both sides by 10, it shows that my a in this case is 4.8 minus 2 root 3. All these meters per second squared. Do not forget to include your units whenever you solve. Do not forget to include your units. So this is the acceleration of the particles. Now with this value of the acceleration, we can now substitute it into any of these equations and determine the value of the tension.